As far as I'm aware, right, this will be a huge interest for professionals and also academics for the Internet of Things and also for the OSI architecture. So concise binary object representation is a standardized data format whose design goals include the possibility of extremely small code size, fairly small message size, and extensibility without the need for version negotiation. This is typically used in IoT machine-to-machine communication to increase the communication speed compared to the previously what we known as the JSON data format. So Isham is, our next speaker from Sri Lanka. Right, he's currently working as a lead software developer for Kloudynet Technologies, a Microsoft partner based in Kuala Lumpur, Malaysia. So he's really passionate about software, architecture, cloud computing, and also connected things. He's also a frequent speaker in both Microsoft Azure cloud events and also IoT related topics across various forums. So ladies and gentlemen, without further ado, please join me in welcoming Isham as he shares with us his talk titled Concise Binary Object Representation, or CBOR, for faster M2M communication.
Yep, thank you. Thank you for your introduction, and yeah, so welcome everybody for this session on CBOR. Yeah, so let's start. And 41.6 billion devices and 79.4 zettabytes. That is precisely, I think, 79.4 billion terabytes is what predicted in case of Internet of Things and in 2020 by the latest IDC report. So the numbers are so huge. And let's talk about CBOR for fast machine-to-machine communication. And I am, by the way, Isham Mohamed, lead software developer for Kloudynet Technologies. So today's agenda is starting with a disclaimer, and we'll do a small compare-contrast on IoT and CPS, and do some quick revisions, and we'll go through what is CBOR and some CBOR implementations and limitations, and perhaps when to use CBOR. So the disclaimer is this is going to be an introductory session for CBOR, and I will because like throughout these years, what I have felt is that whenever we do a few IoT implementations, most of the people are not really aware of CBOR, and we can even see I mean, the well-known cloud technologies, whoever provide support for IoT, doesn't even give proper CBOR support. So I thought to make a bit of an awareness, and indeed CBOR is a RFC standard, and I mean, again, this is not an introductory session for IoT, CPS, OSI, TCP/IP, JSON, protobuf, etc. But I may give some brief introduction about them. So about IoT and CPS. So I mean, if you see, as you can see already in this image, I mean, Internet of Things is about connecting the physical world devices, which can be either objects or machines or sensors or whatsoever, to the Internet, and eventually to each other, so that they can communicate between each other. While CPS, or Cyber Physical Systems, is basically the integration of computation, networking, and the physical process. So usually, like what we are talking about is a smart factory, perhaps, and which has each of these devices talking to each other and sending the data to a cloud, and that is scalable, and that may use technologies like Wi-Fi, 4G, WiMAX, I mean, yeah, and whatnot. And that also has this control, computation, and communication, the 3 C's of CPS. And both these CPS and IoT, like which is the cyber world and the physical world, share common things such as sensors, resource sharing, real-time real-time integrations or real-time systems, data sharing, and coupled physical and computing environment. So in these common five things, what matters that the most is the real-time system, which means the real-time scenario for the decision making. Yeah. Otherwise, like I mean, there's it doesn't really make sense if you don't have that real-time thingy without without that real-time thingy, it doesn't really make sense. So before going to CBOR again, let's go through some quick revisions about the OSI model so that you may easily understand where does this CBOR comes into place and etc. So this is the OSI model. Everybody does know that, like, we have this physical layer, which is about the physical structures such as cables, hubs, etc. And we have the data link layer, which establishes and terminates the logical link with the help of these MAC addresses and stuff. And we have the network layer, which is responsible for routing and things such as subnet traffic controls, which contains IP, etc. Yeah, and we have transport layer, which does the message segmentation with protocols such as TCP and things like that. And we have the session layer for logical ports, basically to talk to the ports like SQL port, RFC, and NFS BIOS names, etc. And we have the presentation layer, which does the character code translation and data conversion, such as, like, this is where the ASCII, UTC, and JPEG related those data codes comes into place. And then we have application, where it does the resource sharing, remote file access, and things like that. This is where the SMTP protocol such as SMTP does come into play. So to make the communication faster, to achieve the real-time communication, what as we do is that we always try to make the protocols perform more in a more optimal way, so that they can consume a very little bit of a time to transport this data from a physical from the physical layer to the application layer, which means from hardware to software. Technically, physical to applications mean that the data is moving through more abstraction, and it's actually moving from hardware to software. Yeah, so people, for example, LoRa, we use in physical layer, we use LoRa for some faster communication. Indeed, there are trade-offs, but still we do some trade-offs to achieve the more optimal or more performant or more high performant way to move the data to the next layer. And at some point of time, when IoT became more famous, people try to move out from it. It's not, people still use OSI as the base model, yeah, but still there are some modified OSI versions. But then we have this TCP IP model as well, which has 4 layers, where, like, some of the layers are basically the accumulated versions of some layers in OSI model. So that's where we have the network access and physical layer for TCP IP model, where all these Wi-Fi and Ethernet and GSM, CDMA, LTE related protocols comes into place. And we have the internet, which is kind of replacing the network layer of OSI model, where IPv6 related technologies comes into place. And we have the exact same transport layer, where we have UDP and TCP, and application, presentation, and session layers are accumulated, and they are known as application layer in TCP IP model, where MQTT, all the transport, all the protocols to communicate are being there. And CBOR. So CBOR comes into place where a fraction of time matters, and as already that was mentioned, it's CBOR is known as concise binary object representation, and this is basically a binary data serialization format loosely based on JSON. So that's the beauty in that, because this is loosely based on JSON, so that if you have your existing system in JSON, moving towards CBOR is really easy. The migration is really easy, and this is again in standard RFC 7049. You can Google for this particular keyword and find more information about CBOR. And this was designed with these design goals in mind. So it should be extremely small code size, because the intention for CBOR is that to be deployed in the constraint environments, so that it should leave less footprint is what they mean, and the message size also should be fairly small, and it should be extensible without the need for version negotiation. And not only these, but also this was designed, that with some more things in mind, like such as they should have the JSON compatibility, and the format must be applicable to both constraint node and high volume applications, as well as the data must be able to decode without schema description. So the encoded data should be self-describing as JSON. So like this is not like protobuf, where you need to have schema defined and contract defined, but when it comes to CBOR, which is similar to JSON, and you don't need to have the schema described prior to use this one. So if we have a look at CBOR and JSON, this is basically the encoded CBOR version of this JSON. So I took this JSON from the GeekcampSG website. So this is how it will look like when you transfer it. And the good thing is that when I try to compare the length or the size of these two messages, without even by ignoring the white spaces and making this JSON to a single line, it took around, I think, 250 bytes. And when I try to get the length of this one, that is like 50 or 60 bytes less than the amount. So, but indeed, this is not human readable, and that's why we say this is for machine-to-machine communication, and like this is not. This is not really suitable for you to have a look at this this particular data, the raw data, and do some debugging or whatsoever. No, you cannot do that thing. So you may, like, if you have this encoded format, you really need to decode it, and since CBOR is in the standard, there are particular tools that are already available for you to decode this one, decode the CBOR, and debug and diagnose the problem whenever if you feel that there are some problems. And this is I took this from a website. So this person is trying to process this message over 10,000 times. Basically, he tried to process an array of JSONs. And this is what they have benchmarked. So for the sizes, as you can see, the JSON took around 798 bytes, and CBOR is 585 bytes. At the same time, the processing time for this message over 10,000 times is 789 millisecond for JSON and 164 millisecond for CBOR. So I think it's around 5 times less than the time to process JSON. So that again, we are trying to make this the transport of the data more optimal. Even though you use 4G or LoRa, or if you use any other technologies, we are we are making this more optimal using CBOR. And some implementations where I have the code also in place. So this is the implementation for CBOR for JavaScript, and this is what you get when you encode the message. So this library, you can get it from here. This is available in GitHub. And if you encode this message, the same JSON, this is what you get. And in JavaScript, it's basically an array buffer with 237 bytes. Yeah. And then this function, I think buff to hex is a function where I try to get the buffer and convert it to hexadecimal format so that I can print it in the console. And these are some other implementations for Python, Go, and you also can find more implementation at this particular URL. Or if you go to cbor.io, you can find more information about this one. And if you see the current limitations, so the first problem is that yeah, CBOR is relatively new, even though this is in standard. So there's no native language support like we have a native support for JSON in JavaScript, and most of the languages like now .NET Framework is also moving towards native support for JSON and things like that. But I mean, there's no actual native language support for CBOR for any languages. So we had to depend on other implementations, open source implementations, and most of the implemented encoders are not really optimal because still people are optimizing those. And again, another one is the lesser known cloud support. So this is where if you see Azure or AWS, when you try to send message from a device to that cloud, like to the IoT hub or anywhere else, usually we use HTTP over JSON or MQTT or AMQP. But that's what usually they all support, all the famous cloud vendors like AWS or either Google or Microsoft do support a JSON format of HTTP, but none of them, I think, so far supporting CBOR. Even though Google has some support for CBOR for the device to cloud communication, but still, that's not that's not supported as they support JSON. And when to use CBOR? So it's basically a better alternative for a large JSON raw data chunks. So in most cases, I think JSON still seems better option because because of two reasons. One is that there's no native language support, and there is the current implementations can be again optimized. So still, if you compare to the native JSON support, still JSON seems more relevant when you have small JSON and things like that. And when you deal with large numeric arrays, so that's where JSON won't even help you. JSON won't give an additional value because those are just some numeric arrays and there's zero readability. So you can simply encode that as a CBOR and do that thing. And then when you try to do the application migration from JSON to something better. So if you feel like your current system, if you want to optimize your current IoT system, which already uses JSON, and I mean, one very obvious option is that proto buffers, but the thing is that you may still need to do some additional implementations to support proto buffer, because proto buffers are contract-based ones. So you need to define the schema in both receivers and sender party and things like that. But with but if you go for CBOR, you can, I think you can go for a very easy migration from JSON to CBOR, because it's a game. You just need to encode, and then you on the receiving part you just need to decode it. Yeah. I think that's all from my session, and yeah, I think maybe I can answer a couple of questions if there are any.
Live event Q&A, and I see that there hasn't been anyone for Isham so far. We'll give it everyone 30 seconds more to see if there's any questions coming in. Yep. As we're waiting for the questions to come in, Isham, I think just want to say a big thank you to your awesome session, CBOR, and also learning a lot from you as well.